your personal mail ID. Any more confusion?
Good morning, sir.
Good morning. So I think it will be like this only. It is showing 68, 69. Anyway, do you find any page there shared on your screen?
Yes, sir.
Yes, sir.
So this was problem 1, and if you see that problem sheet, what has been mailed, the solution is completely given there. So as sample. Next thing, regarding problem 2, this was discussed. 2A, 2B, these solutions are printed there, and it was asked that C, D, E for different values on the VP, on the HP, and on the ground line. That also we discussed. In problem number 3, the statements were like this. For 3 different problems, or 3 different parts of this problem, 3A, 3B, and 3C. 3A part is here with the given dimension. Draw elevation plan and view from left of the line AB when A is 10 millimeter above HP. So this is 10 millimeter above HP point A in elevation A dash. 20 millimeter in front of VP. It will come in plan. So small a, this is the notation, 20 millimeter below the XY line. For B, B is 40 millimeter above HP. Above HP means it will come above the GL or XY line, and this distance is 40 millimeter and 45 millimeter in front of VP. So this is the distance of plan B, 45 millimeter. But this line connecting A dash and B dash, these two are rigid, indicating the distances 10, 20 and 40, 45. But this distance between these two projectors connecting A dash and B dash, it is mentioned 40 millimeter. So at a distance 40 millimeter, we draw this line and mark this point B and B dash along this vertical projector line, measuring these distances 40 and 45. So that is the detail of 3A part. And view from left. For view from left, you need to show one more axis thing, and it is just hold a minute. So this is the axis. Then from 4 different plan elevation points, we draw these horizontal projectors, or you start with this one, draw this 45-degree line. Then through A and B in plan, draw these horizontal lines to reach to this 45-degree line here. Then project vertically, or draw this vertical projection line and corresponding levels or heights of A and B. In elevation, it will be A dash and B dash. So get these 2 points, A double dash, B double dash, and join this line. So ultimately, this is elevation of AB. This is plan of AB, and this is view from left. Okay, now for the second part, it is in some special information. A point is on HP, 1 point on VP, and the distance between the projectors, those things are given. And I think we discussed it in detail, and that is, let us go through the statements. For 3B, draw elevation plan and view from right. View from right means the axis will be on this side. For plan elevation, axis will be on left. Here, for view from right. Line CDC is on HP and 30 millimeter in front of VP. So C is on HP means distance from HP is 0. So elevation height is 0. And this plan distance, it is 30. Correspondingly, point D is on VP. So when D is on VP, So distance from VP is 0. Distance from VP you get in plan. So distance from XY line for the plan D, it is 0. And height, it is 35 millimeter. So you understand these two locations in plan elevation for C and D. The distance between the projectors of C and D being 40 millimeter. So this distance 40 millimeter is now satisfied. So first you identify the position of C dash at a distance 40 millimeter. You draw a vertical projector line. There you identify the location on the XY line, that is for plan D. Next, at a distance 35 millimeter, you identify the elevation of D. Then you join the small c, small d in plan, small c dash, small d dash in elevation. So these two are the corresponding or the required plan elevation of the line CD. For view from right, draw this axis on left of this plan elevation. Then C, through C we draw a horizontal line to meet this axis. Then draw a 45-degree line here. Bring it on the XY line. That means the distance 30 millimeter is maintained here. Distance from the vertical plane. Distance from the vertical plane inside view. Now for point D, distance from the vertical plane, it is 0. So naturally distance from the vertical plane, which is identified here, it is on this line itself. And along this line, the side view will be identified, view from right. And join now C double dash D double dash. So this is the required view from right. So please follow these steps very carefully and go through this information what is given there in terms of the distance from the reference planes HPVP and in terms of its position or in terms of its this distance between these projected lines through C and D. Now part C is a little different from these formal practices or whatever we have done up to this. Draw elevation plan and view from left of the line EF when E is 45 millimeter above HP and 10 millimeter in front of VP, while F is 15 millimeter above HP and 40 millimeter in front of VP. So individually we can identify the point E and F. So if this is the XY line, for E, E is 45 millimeter above HP. So if we draw this projection line or this projector 45 millimeter here will give us the elevation of capital E, that is indicated by small e dash. And what about the plane? 10 millimeter in front of VP. So this is 10 and name is small e. Similarly, for point F, for any projector, when plan and elevation will be located on that projector line only, which is perpendicular to XY, then what about F 15 millimeter above HP? So this is 15 elevation of F and 40 millimeter in front of VP. So this distance is 40 below ground line or the XY line. This is plan small f. Now these two are the primary information about the position of this pair of points. Now once we have that pair of points for E dash in plan elevation and F dash in plan elevation, then comes the question of the other information. The projector of E coincides with that of F. So if we have, this is the ground line, suppose, then we draw the projector line. Projector line should be very thin. This is the projector line. For E dash and F dash at 15 millimeter, and below XY plan will be coming. For E, it is at 10 millimeter and F at 40 millimeter. So this green line is the projector line, and the straight line will be connecting capital E. So naturally it will be in plan and elevation, the same thing. We connect E and F in plan. This is the plan of the straight line, and in elevation we connect E dash and F dash. That is the elevation of the line EF. And this is plan of EF. Okay, so on this line, as it is drawn, as you see here. Now let us make it a little bigger. Sorry, it is going out of the screen, so let us accommodate it. Now I hope it's fine. So can you hear me?
Yes, sir.
Okay, so on this projector line, which is shown here, mark these distances: 15 millimeter, 45 millimeter, this 10 millimeter, and this 40 millimeter, and join these distances between E and F, or this position between E dash and F dash. We get the elevation and plan. Now next part of this problem is to draw the view from left. Now to draw the view from left, the formal way is draw this side view axis, then that distance to be maintained as the distances from vertical plane, either the circular arc, 90-degree circular arc, or corresponding to this 45-degree line, whatever way you feel comfortable. But here we have done by this way: draw a horizontal line to reach this side view axis, draw a 45-degree line, reach this XY line or horizontal line, draw a vertical projector line, and it will reach up to the level for this corresponding point, the elevation level. So this is the side view from left for the point E. Similarly, for F, the distance from vertical plane 40 millimeter is satisfied here, 40 millimeter. So draw a horizontal line, draw a 45-degree line, reach to this point, draw a vertical projector. Then you need to reach up to this limit, that is elevation. So side view cannot be at a higher level or lower level compared to the level shown in elevation. So this is the corresponding point. Now we join E double dash and F double dash to get the view from left for the line EF. Now, can anybody tell me any special information whether it is there for this particular problem? The line EF is parallel to the profile plane. Do you get my point? Suppose you are working with your laptop. The laptop keyboard is your horizontal plane. The laptop screen is your vertical plane. You place it vertically, and we can consider this as the HP-VP combination. Now you take a set square which is standing vertically on your keyboard, and the base of the set square which is touching the keyboard, it is perpendicular to that corner line, the XY line. And it happens something like that. You connect the diagonal E and F, and in plane as well as in elevation, you will get both are perpendicular to the XY line, because it is coming as a simple thin sheet like thing, as if a plain piece of paper, and you are holding it just in front of eyes, between your two eyes, and simply perpendicular to your face. So naturally you will find all the lines located on that set square or on that piece of paper, everything you'll find coming on that straight line, projected on the HP and VP as well. Okay. Is it clear? Now this idea will be utilized afterward when any line or any plate like thing is parallel to the side plane or that profile plane. Okay. Now let us discuss something very basic. Now let me erase this thing off, which are not necessary right now for that discussion. Now we started from a particular point. Then we consider 2 points. For our convenience, we take the position in the first quadrant, that means above HP and in front of VP. Then if we consider 2 points, capital A, capital B, then identify its plane and elevation and connect these 2 points by a straight line. Now this connector must be perpendicular, a single line, and plane elevation is located on that line. And as you know, when you open that space from 90 degree to 180 degree, or just rotating through 90 degree about the XY line, naturally it will be coming in that way only. So that projected line should be always perpendicular to the XY line or the ground line. Similarly for B and B dash also. Now when we connect A and B, we get a straight line, and when we connect small b, we get the plane of that line, capital A, capital B. And when we connect A prime and B prime, or small a dash, small b dash, in elevation, we get as a whole the elevation of the line capital A, capital B. Am I clear? Now, in this information, it is never mentioned the straight line is of this much length, or the angle made by the straight line with HP or VP are like this. These are not mentioned in that way. But at least we can think, if there are 2 points A and B, connecting those 2 points capital A, capital B, it will give us the real line, and individual planes small a, small b, when you connect, you will get the plane of the line. And when you connect the individual elevation of the points capital A and capital B in the form of small a dash and small b dash, we get the line after connecting those 2 points, the elevation of the line capital A, capital B. Similarly, if we have one more point, capital C, and we join by straight lines this pair of points A and B, B and C and A, then what about the shape of that geometrical figure? Connect A and B, connect B and C, and connect C and A. So what geometrical figure you are getting?
Triangle.
A triangle.
Triangle.
So individually for A, we have its plane, we have its elevation. For B, placed in first quadrant, it has its plane and elevation. Similarly, for C also, its plane and elevation. Now, if you connect the plane points A and B, B and C and A, we get a triangle ABC, and connecting these elevations A dash B dash, connecting B and C in elevation, connecting C and A in elevation, we get the triangle A dash B dash C dash. This is plane of the triangle, capital A, capital B, capital C, and this is elevation of the triangle, capital A, capital B, capital C. So you can think as a whole about the triangle, or you can think individually the distinct points or the vertices or the corners of the triangle, capital A, capital B, capital C. But in both the cases, ultimately we are going to draw as a whole the plane of the triangle ABC and elevation of the triangle ABC. It's not like that we are talking about three distinct locations A, B and C. And indefinitely you can move A or move B or move C. That movement will be dependent movement because other points are connected. So if there is a point A, another point B and the third point C, so once you join these three sets of pair of points A and B, B and C and A, we get a rigid boundary. So that important information along with some more information like that what is the angle made by that triangular plate ABC with horizontal plane or with vertical plane, etc. Now corresponding to this thing, if you go through the instruction sheet and if you go through the problem 5, now can anybody open that diagram page, that is a third page of plate number 3. Quick. Now after this problem number 5, I will close the class for your preparation for the mid-semester examination. Just quickly somebody open that page and read out the problem statement. Problem 5. And that day I advise that take these 3 pages printout from your local photocopying shop. बेटा हार्ड कॉपी का कोई जवाब नहीं है, सॉफ्ट कॉपी तो है ही, बहुत काम की चीज है, बट हार्ड कॉपी
सर ये सॉल्यूशन करके कब सबमिट करना पड़ेगा?
अरे बेटे तो पहले प्रॉब्लम नंबर 5 बता क्या लिखा है और डायग्राम क्या है। सबमिट करना होगा कि नहीं होगा मैं बताऊंगा बाद में।
सर टू
पहले तो
व्यूज ऑफ
सब्जेक्ट
एन
सीख ले।
irregular pentagonal lamina. So problem number 5 is stated as two views of an irregular pentagonal lamina are given in figure problem 5. Copy the views and draw view from left.
Okay, so two views of an irregular pentagonal lamina are given in fig prop 5. Copy the views and draw view from left. So this is that pentagonal lamina whose diagram is given. Now one thing, pentagon is irregular, but this is the elevation, which is a regular diagram. All the sides are 30 millimeter, 30 millimeter, 30, 30 and 30. Now, can you tell me what is this line? The black line at an angle 30 degree?
Axis.
No,
Sir.
no, sir.
Sir, the line joining the two corners.
Now, there are 5 corners for this pentagon.
Yes, sir.
Okay. Now, when we have those 5 corners, we should identify, suppose these are showing the elevation. So, A, B, C, D and E in elevation. Now those letters are prominent there on your screen.
Yes, sir.
Now this is elevation. This is XY line or the ground line. This is VP side where elevation is available, and lower side is HP side where plan is available corresponding to that first angle. Now this, when if we talk about a set square suppose or a cardboard in its vertical orientation, then if you see from top, can you get that shape of that pentagon? What about the shadow? If we project some light from top and at the bottom of that light source, one vertical plate is there. So what about the shadow on the horizontal floor? It will be a straight line. Okay, and on this straight line, which is the plan of the pentagon A, B, C, D, E, and this is the elevation of A, B, C, D, E. Then if we draw the projector, definitely this will be C. This end will be E. Now this point D comes at the middle. And draw vertical projectors through elevation of A and through elevation of B. It will be the plan location for point B and this will be the plan location for point A. Very important and basic. So without understanding this basic information, we cannot move forward. So with all such primary information, This is the elevation of capital A, capital B, capital C, capital D, capital E, that pentagon. And this is ABCDE, small a, small b, small c, small d, and small e. These are the corners of this pentagon. And when we connect all these individual pairs of points, AB, BC, CD, DE, and EA, we get the boundary. And this boundary in elevation, this is the ABCDE in elevation. And for this special situation, ABCDE in plan are located on a single straight line. Now, when we get that view, a single straight line, when we project that flat surface on a plane which is perpendicular to that, that means if you take a vertical cardboard, the shadow on the horizontal floor will be a straight line. Similarly, if we consider a cardboard perpendicular to the wall, that is the vertical plane, the projection will be a straight line. Now, for this particular case, one pentagonal lamina is standing on the floor. Okay. Now, next part. Now, its problem statement was from the supplied figure, irregular pentagonal lamina. Copy the views and draw view from left with the given dimension. Dimensions are 30 mm side regular pentagon and 10 mm distance from HP and VP. So these are 30, 10 and 10. Okay, so corresponding to those, elevation points are supposed with the names A, B, C, D, E. In plan, there will be A, B corresponding to this elevation of B, C corresponding to elevation of C, D corresponding to elevation of D, and E corresponding to elevation of E. Next part, draw the view from left. So draw this 45-degree line. From A, we draw a horizontal line, reach here, then draw this vertical line through A and reach to the level of A. So this is, level of A means here. So plan and elevation, they're matching in this way. It will be A double dash. Then for B, the horizontal line, reach this 45-degree line here, project it and move up to the level B. So this is the level B. So this becomes the left view for point B. Similarly for C, the horizontal line, reach the 45-degree line, draw a vertical line and reach to this level of C. This is C double dash. Similarly D, this middle point, come here, project it vertically, then reach up to this level. This will be D double dash. And similarly for E, at this height. So join A double dash with B double dash, B double dash with C double dash, C double dash, D double dash, D double dash, E double dash, and E double dash, A double dash. So once it is there, this is the view from left. It will be a pentagon again. But this special situation, when that pentagon comes as a straight line in some projection, it means the pentagon is perpendicular to that plane of projection. So on horizontal floor, you are getting a straight line. It means the plate is in a position that it is vertical. Okay. Vertical, but inclined to the vertical plane at an angle 30 degree. So these dimensions must be mentioned. This distance, it must be there. And for our convenience, we should give the names of these corners of this pentagonal lamina or plate. Okay. Otherwise, there is a possibility of mixing up with one plan point to other elevation point. So plan elevation for A, this connector is here. The projector connecting plan and elevation of B, it is here. For C, this line. For D, this line. And for E, this one. For side view, through A, B, C, D, etc., draw the line to reach up to this 45-degree line. Those points where they reached, draw vertical projector, and that height along this vertical projector should be limited to that height only, or exactly at that height. These are the heights: 10 millimeter height of A, height of B, then this angle. But the very first thing, that this diagram corresponding to a regular pentagon. So what is the process of drawing this? Draw a line parallel to horizontal plane, because when you are going to copy this, so naturally at a distance 10 millimeter above XY line, draw a line which indicates AB. Now from AB at an angle 72-degree, draw a line and just mark a distance of 30 millimeter. On this side also at an angle 72-degree, mark a distance of 30 millimeter, and these will be the points in elevation for C and E. Now next thing, either using this angle as 108-degree, or the simple thing is that draw this middle line. Okay, so at this, on the central line, you take one intercept, that is making C dash as center, taking 30-degree as radius, draw one arc and intersect on this center line. So this will be the point D dash in elevation. So that geometrical simplification, it comes from practice, and once you do all these things with your own hand, your own instruments, so naturally you will build up that confidence. Okay. Now, do you have any question here corresponding to this problem 5? Because I am going to close the class, because we have, as per your request, you are going to take preparation for your mid-semester examination. Any question?
Sir, why do I have to submit this problem, sir?
Regarding submission, I am not asking right now anything. All these things are for your practice. You should do this practice well, so that any problem you can take up yourself confidently. The 23 problems mentioned in this plate, this is not just enough. There are so many varieties of problem what you can get from different books. But these primary discussions, it will clear the confusion. It will give you that background or base or that confidence regarding this subject, so that you can move ahead. So do the class attentively. Then with your personal practice, make your confidence. Then whatever problem you can face, if there is anything at all, after all such process, we will discuss in the class. And regarding submission, I will give you separate assignment when and what to submit. Okay, but before that you must understand the subject. Any more thing?
Okay, sir. Thank you, sir.
Okay. Now,
Sir, I have a question regarding trusses.
regarding trusses, ये बेटा ड्राइंग के अंदर ट्रस कहाँ से आ गया? ठीक है
Yes, sir.
बेटा बोल. But before that, I need to do this important thing, that is whoever may be the present in the class, only 110 including me. So just download the attendance list. Let us wait for 1 or 2 minutes. It has started downloaded, and I will check whether it has been stored in my download folder or not. today. It's done. So if you have nothing to ask about this projection of point line surface, then we will shift to some other discussion as per your requirement, but it is outside the class, because many people will leave the class now and go for their individual subject preparation, and whatever discussion it will be here, so naturally you should not ask me to repeat it on some later day. Okay, so those who are having some doubt regarding anything, you can ask. Okay बेटा बोलो, ट्रांस के बारे में क्या पूछ रहे थे?
Sir, what is the what sir,
What is the
difference between roller support and what is the difference between roller support and hinge support?
roller support and hinge support? Suppose you take a pencil, allow it to rest on your table. Okay, समझा? यार कुछ बता. You take a pencil
Yes,
and you are
Yes, sir.
simply placing on the table. Now you take one scale, whatever it is there in your hand. Suppose you take a scale and try to move on that pencil. You place it on the pencil and you just try to move across the pencil. Then what happens?
The
Pencil will roll, or pencil will allow that scale to move over this, so there is no restriction in translation for that scale. So when there is no restriction in translation and movement along horizontal plane, so there is no horizontal reaction. Reaction will be there only when there is some restriction against the movement. Okay. Now suppose a ceiling fan.
Yes, sir.
It is hanging from the ceiling, and that ceiling is obstructing it from it being falling down. So whenever it is not falling, definitely some reaction is there corresponding to the applied force, that is the weight of the ceiling fan, and that reaction is developed in the hook
Yes, sir.
connected to the ceiling. Now hinge means it is
Yes, sir.
as if suppose you make a hole there in that scale. If you take a steel scale, steel ruler, there is a hole. Okay. Now you
Yes.
insert some needle through that and try to pull that steel ruler, holding the pin tightly in its position, or holding that needle which has been placed through that hole. There you will find the steel ruler can swing or rotate about that needle which has been inserted through that hole, but you cannot move apart from that pin location or that hinge location. So the translational movement is restricted. Only that rotation is allowed.
तो उसमें दो reaction.
So whenever there is some translation movement is restricted, so along the direction opposite to that direction of restriction of translation, there will be one reaction. Now you hold a needle through that hole made in that steel ruler, and now you try to pull it along 30-degree inclination through to the horizontal.
Yes, sir.
Okay. Now when you are trying to pull it along 30-degree direction, so what about the reaction? It will be opposite to that applied force, which is along 30-degree. So along 150-degree direction, there will be one resistance, which is called the reaction developed at the pin. But normally we consider the horizontal and vertical component along x and y direction. So that 150-degree reaction force is resolved into two components, that is that reaction multiplied by cosine 150 and that reaction multiplied by sine 150. So if this is the hole, this is the pin, and here is a ruler, that scale, and here is the pin. and if you are trying to apply some force here, suppose hold it with your two fingers on your left hand, this pin here, and with your right hand you are applying a force here, but it will not move. Only thing, you will feel some or experience some pain in your two fingers of left hand, that is due to this applied force. So there will be one reaction when it is not moving in that direction. That reaction is of same magnitude F. Direction is opposite to the applied force. But normally we do not work with this force R as a whole. What we do, instead of considering that full reaction as a whole, what we consider, we resolve this reaction force in two directions, X and Y. And here will be the reaction R having component Rx and having component Ry. Now, when we consider this Rx and Ry separately, we do not include this R in calculation because it will be double inclusion of that same force. So either you consider as a whole this R, or its individual component Rx and Ry. Now, not necessarily X and Y direction will be the reference direction only. Okay, there may be any reference direction for our convenience. Maybe there is one direction which is U, and another direction perpendicular to that U is V. So this component along U direction, it will be U component of R and V component of R. But simultaneously you cannot include R along with RU and RV. You should not. So according
Yes,
to
sir.
your convenience, you resolve this force in any two mutually perpendicular direction. It may be XY, it may be UV, it may be NT, that is normal direction, tangential direction, whatever may be. But either you consider the reaction as a whole in terms of R or in terms of its components. If this angle is theta, then RU is R cos theta and this is R sin theta. But its direction will be opposite to the actual positive direction of U and V. So they will be negative, negative. So either you come from that geometry directly or using the general description of the angle. Suppose U positive axis, from that you measure in anticlockwise and you can represent it as theta. So R cos theta, it will automatically give you some negative value, and R sin theta, that you will get automatically that negative value when that angle is coming in the third quadrant. Sine, cosine, both of them are negative. So it automatically includes this negative component here, or physically you can mention this angle. If it is 150, it will be 30 degree here. So that R cos 30 in this direction obviously negative, and R sin 30 definitely it is in this direction, and that is negative V direction. But this is the primary idea between the pin connection and the roller connection. Now symbols of roller, in some book it is like this, in some book it is like this. Sorry.
Yes, sir. Got that thing.
So this is something like a pencil placed on your horizontal table, and suppose you place a finger on that pencil and try to move it across the pencil. It is something like that. You can lift this at your choice. So that translation is not restricted in vertical direction, in upward direction. Only thing that translation is not allowed in this vertical downward direction. Translation in horizontal right or left, these are allowed. Here also allowed. So reaction will be only corresponding to this restriction against movement. और कुछ
Yes,
पूछना है बेटा किसी को?
No, sir. What is
Okay. So now we can stop our discussion, and as you told that you need some preparation time for the subjects other, so that you can do. And if you feel any common discussion session you require from me, then let me be informed, and we'll send you that meeting schedule for MS team. Okay. So तब तक के लिए आज्ञा दीजिए.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Most
Thank you,
welcome.
sir.
Thank you, 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 sir. Good night.
Thank you, sir.